Hello ladies and gentlemen, welcome to my video. This is today's question. So where do we start? I think we can solve it using integration by parts and then with the trigonometric substitutions. Let's rewrite the question become integral 0 to infinity u dv, where both u and v's are function of x. We can define u equals to inverse tangent x. Therefore, differentiate we get du equals to 1 over x squared plus 1 and then multiply dx. Meanwhile, we define dv equals to x and then divide by x squared plus 1 and then power 2 dx. With some experience, we know the integral of this function gives us a v, which is equals to negative 1 divided by 2 and then multiply x squared plus 1. Go back to q, it can be rewrite as uv and then minus integral v multiply du. From here, q become negative inverse tangent x divided by 2 and then multiply x squared plus 1 for x equals to 0 and x equals to infinity. And then minus integral 0 to infinity negative 1 and then divide by 2 x squared plus 1 power 2 dx. For now, we focus on the part number 1, which is L equals to L infinity minus L0. L infinity equals to limit x tends to infinity negative inverse tangent x divided by 2 x squared plus 1. Put in x equals to infinity, that gives us negative pi over 2 divided by 1 over 0, which is equals to 0. L0 is much easier. Put in x equal to 0 to the equation. We have negative inverse tangent 0 divided by 2, which is 0 divided by 2, which is still equals to 0. So therefore, we obtain L equals to 0. In another word, Q equals to the second part, which is 1 over 2 integral 0 to infinity and then 1 over x squared plus 1 and then power 2 dx. What is the next step? Don't worry, we can continue using trigonometric substitution. Define x equals to tangent t. So differentiate, we obtain dx equals to secant square t and then dt. From the equation we define, we obtain t equals to inverse tangent x. The integration bound, when x tends to infinity, t equals to pi over 2. When x equals to 0, t equals to 0. Therefore, q equals to 1 over 2 integral 0 to pi over 2, 1 divided by tangent square t plus 1 and then the whole denominator power by 2. Don't forget multiply secant power 2t dt. We know that tangent square t plus 1 is equals to secant square t, which means the integrands become secant power 2t divided by secant power 4t. Of course, it means the integrand become cosine square t. Next, we are going to use double angle identity, transform it become 1 over 2 integral 0 to pi over 2, 1 over 2 and then multiply 1 plus cosine 2t and then dt. This is directly integratable, which become 1 over 4 and then multiply t and then plus 1 over 2 and then multiply sine 2t for t equals to 0 and pi over 2. Put in t equals to 0 and t equals to pi over 2 into the equation. We obtain 1 over 4 and then multiply pi over 2. The rest are just 0. That brings us to the conclusion of this video. The final answer of this question is pi over 8. Thank you for watching this video until the end. Please continue support my channel, subscribe, give a like and share my video with others. See you soon for my next video. Bye bye.